Today's lesson is on like terms with algebra tiles. When we are working with algebra tiles and like terms, we need to group all the same shapes together. That means putting the big squares together, the rectangles together, and the little squares together. We're going to remove zero pairs, and then we're going to write the remaining shapes as a polynomial. What's a zero pair? A zero pair is when you have two different colors of the same shape. You have a positive x squared and a negative x squared. When you add those together, you get 0. That's why it's called a zero pair. If you add positive x and negative x together, you get 0. And if you have positive 1 and negative 1 and you add those together, you get 0. A polynomial is in simplest form when it can be drawn using the fewest algebra tiles possible. And just as a reminder, the big squares are your x squareds, your rectangles are your x's, and your little squares are your units or your ones. Okay? Now, let's take a look at this example. It says, to simplify the polynomial pictured below, write your answer in symbolic form. So the name of the game here is simple. Put the rectangles together and put the little squares together in that order. So we can't color things very easily. So for us, shaded is going to represent positives. Unshaded is going to represent negatives. So I'm going to put two unshaded rectangles along with one shaded rectangle. And then I notice all my little squares are all shaded. How many little squares do I have all together? Thank you. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade all of them together. And once I have written all my rectangles together and my little squares together, I'm going to go looking for a zero pair. And in this case, there is a zero pair right here. They add together to give us 0. So, okay, crossed out. Sometimes we cross out a lot of stuff. So because sometimes we cross out a lot of stuff, it's important to write out the polynomial after you've crossed out stuff. So I'm going to draw out the one remaining rectangle, and then I'm going to go ahead and I'm going to cheat a little bit here. There we go. But there is my little squares. Now, I'll give you a second to draw that out. Now, we have to use a letter to represent the rectangle here that's left. We can use any letter in the alphabet. X is the universal variable, so let's use X, I suppose. Is it positive or negative? Negative, because it's unshaded. That's right. And then all the little one tiles are positive because they're shaded. And how many of them are there? 8. So we write it out as negative x plus 8. And that's what we have to do for this question. So just to recap, we put all the shapes together. That means we gathered up the rectangles and gathered up the little squares. We made as many zero pairs as we could. Then we drew what was left, and we converted it into a polynomial. All right, we're going to do the same thing for the next one. Here, we got big squares and little squares, so time to put them together. So make sure when you draw these big squares, you shade them. Anything that's shaded is positive. So I have redrawn this with our big squares together and our little squares together. I'll give you a moment to get that drawn yourself. So we look to see how many zero pairs we can make. Here's a zero pair right here. A shaded big square and an unshaded big square. Then we have one shaded little square, one unshaded little square. 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 And then we'll draw what we have left. So we have two big shaded squares left. And how many unshaded little squares? 5. Very good. So we have that left right there. In this question, we haven't been told what letter to use. So let's use the letter A. We have 2a squared and then minus 5 for the unshaded little squares. Okay, next up. We skip the next question just as a matter of time. I want to give you a little bit of time to work on this. So we'll go right to the next example, which is simplify using algebra tiles. So this doesn't give us a picture. We have to draw the picture. So 2p is going to be what? How do we draw 2p? What are positive rectangles? Shaded. Very good. 2 shaded rectangles. Awesome. How do we draw in plus 3? 3 shaded units. Sure. Then we have minus p. How do we draw in minus p? One non-shaded rectangle. Very good. How do we draw in plus 1? What do we do? One shaded unit. And how do we draw in minus 4p?
4 unshaded rectangles.
Beautiful. All right. So once we draw that all out, it becomes apparent to us that we've got rectangles and units or one tiles. So our next step is to arrange them together. Put all the rectangles together and put all the one tiles together. So that means we have 2 shaded rectangles along with 1, 2, 3, 4, 5 unshaded rectangles. In addition, we also have 4 shaded one tiles when we put all the one tiles together. So we draw all of the like shapes together. What's our next step?
Put it in symbolic form.
Not yet.
I'll find the zero pairs.
Good. Are there 0 pairs for the rectangles?
Yeah.
How many of them? 2. This guy is going to make a 0 pair with this guy, and this guy can make a 0 pair with that guy. So there are 2 0 pairs. And there's no 0 pairs for the 1 tiles because they're all the same. They're all shaded. And that's how you know when there's no 0 pairs, when they're all shaded or all unshaded. So then all we need to do is redraw this all out. Redraw it out without all the scribbles or the scratch outs to show what we have left when all the dust settles. And in this question, because we started with the symbolic form, we know we're using the letter P. So using the letter P, tell me what the answer is, please.
Negative 3p plus 4.
Negative 3p plus 4. Very well done. Last example. Here we go. So we got g squared. So that's 1 shaded big square. Minus 3g. That's 3 unshaded rectangles. Plus g squared. That's another shaded big square. Plus 4. That is 4 shaded 1 tiles. Then we have minus 7, which is 7 unshaded 1 tiles. And then we have negative 2g, which is 2 unshaded rectangles. All right, time to start putting those light shapes together. How many big squares do we got? 2. And they're both shaded. So there'll be no 0 pairs there because they're both the same. When we look at the rectangles, we see they're all the same too, but the rectangles, are they shaded or unshaded?
Unshaded.
And how many of them are there? 5. So we're going to draw on 5 unshaded rectangles. Again, they're all the same, so that means no 0 pairs. Then we'll draw on our 1 tiles. We have the 4 shaded one. We have the 4 shaded 1 tiles, and then we have 7 unshaded 1 tiles. How many 0 pairs can we make? 4. 1, 2, 3, 4. So when we do that, we can then draw out the tiles after the 0 pairs have been discovered. Of course, the big squares and the rectangles are unchanged because they didn't have any 0 pairs this time around. How many 1 tiles are left after our 0 pairs?
3.
It has 3, and they are unshaded. In this question, we use the letter G. So our answer should also be using the letter G. What's our answer?
2g squared. Take away 5g. Take away 3.
Very good. And that's it for figuring out like terms and simplifying them using algebra tiles.